Greetings and welcome to lecture number 6 on unit number 1, properties of fluid. This lecture we are going to discuss the another important property of fluid, that is vapor pressure. Vapor pressure term is analogous to the saturation pressure in thermodynamics. In simple word, we can say the vapor pressure, it is the pressure exerted by vapor on the liquid surface. So generally, this vapor pressure phenomena occurs because of continuous escaping of the molecules from the liquid surface. As far as saturation pressure is concerned, it is the pressure corresponding to boiling point, and again, it is the pressure at which liquid starts boiling. That is called as the saturation pressure. So, in order to understand this vapor pressure, first of all, we'll discuss what is evaporation and boiling. Evaporation is generally taking place at the liquid vapor interface. So this is a liquid surface, and whatever the molecules escaping from this liquid surface, that is because of evaporation. We cannot visualize evaporation process most of the cases. And it's a slow process without any changing temperature. So even for atmospheric pressure, water evaporates. So naturally, because of the cloud forms and rain falling takes place. That is because of this natural process. Boiling, on the other hand, it generally occurs at the solid liquid interface. So here the bubble formation takes place. So obviously, due to boiling, the pressure increases, and the bubble formation process means here the vapor pressure is overcome the atmospheric pressure. So at the atmospheric pressure, there is no vapor you can see here. So again, the vapor pressure is related to that. So vapor pressure term, we can say uh, all the liquid possess a tendency to evaporate and vaporize. So even if we expose any liquid in a container at the atmosphere, so vapor starts releasing from the liquid surface, but it is slowly, and that occurs because of continuous escaping of the molecules through the free liquid surface. So in the magnified way, you can see there is a molecular movement at the free liquid surface, and some molecules escaping from the liquid surface. And when the liquid is confined in a closed vessel, if you see in this case, this is open, that's why it releases to the atmosphere. But if we confine it in a closed vessel, then the ejected vapor get accumulated in the space between free liquid surface and the top of the vessel. So obviously you can see there is a pressure rise because of the accumulation of vapor. And this accumulated pressure vapor exert a pressure on the liquid surface, uh, which is known as a vapor pressure. So vapor pressure terminology is like this. So you can see whatever the ejected vapor, it gets accumulated in the space between liquid surface and the top of the vessel. And you can see on the pressure gauge also, there is a rise in pressure, slight rise in pressure. And this accumulated vapor of liquid exert a partial pressure on the liquid surface, and that is called as a vapor pressure. So this is a simple phenomenon, that vapor pressure. Vapor pressure is actually varies with temperature and pressure also. If you see here, as the temperature and pressure increases, the molecular movement increases and the vapor pressure increases. So as molecular activity increases with temperature and pressure, the vapor pressure also increases. Higher the vapor pressure, more volatile is the fluid. The petrol is more volatile than water. You can see the two containers, and obviously we can easily recognize which container is filled with the volatile fluid. So obviously the container where the vapor molecules are more, so the have a higher vapor pressure because more molecules you can see of vapors. So the petrol, we can say, is more volatile than water. And on the other hand, the mercury has a very low vapor pressure and high density. Therefore, it is used in manometer. Manometer, we can see the manometric fluid, which is generally exposed to the atmosphere. So the low vapor pressure fluid is recommended there because even if we use water, so after maybe 1 month, 2 months, the water gets evaporated slowly. So that's why the mercury is used. Mercury has a very low vapor pressure and high density. Therefore, it is used in the manometer. You can see from this picture also, this is this fluid as having a very low vapor pressure because only there are three molecules present here. On the other hand, here the more number of molecules means comparatively, this liquid has or this fluid has a higher vapor pressure. This way we can compare the higher the or in the same fluid, if we go on increasing the temperature, obviously the molecular activity increases and the vapor pressure increases. Vapor pressure increases with temperature as well. The main phenomena that is called as a cavitation, it is because of vapor pressure. Because if you see, because of vapor pressure, if the vapor pressure is low, the bubbles are formed, and the bubbles are generally formed at the low pressure. And if that bubble enters into the high pressure zone, it get collapse, and where the high impact pressure generates. And this pressure developed by collapsing though is so high that the material from the adjoining boundaries get eroded. So that impact is very high, and because of this continuous impact at a particular location, that is, this is a impeller of a pump, the material gets eroded and the cavities are formed. And these cavities are formed, and there is a possibility of damage of the component as well as leakage. So this phenomena is called as a cavitation. That is a formation of cavity because of continuous impact of high pressure bubble at the high pressure zone. Because due to vapor pressure, if the vapor pressure is especially low, then the bubbles formation takes place, especially in the pump case. At the suction side, pressure is very low. If the pressure there falls below atmospheric, then or below vapor pressure, the bubbles are formed. Then that liquid enters into the high pressure zone, especially in the impeller side, and where that bubble get collapsed. And if the bubble close to this vicinity, if it get collapsed, all the liquid is rushing towards that particular portion, and the erosion takes place or cavities form. So this phenomenon is called as a cavitation. So cavitation, this is actual visualization. We can see because of this cavitation, this erosion is taking place and the damage of the impeller is taking place, and also how to recognize where there is a cavitation is taking place. Suppose this is a pump impeller, and if there is a vibration is taking place, one of the reason is that that maybe the vapor pressure is low at some locations, and the bubble formation takes place, and the bubble get collapse at the high pressure region, and because of that, vibration is also taking place. So this cavitation phenomena is because of the vapor pressure. That's why the care is taken while designing pump, especially for petrol, that there should not be any bubble formation take place, especially at the low pressure zone. Uh, so this this generally happens with the fluid having a very high vapor pressure, like petrol. So if you take one particular problem in the water distribution system, the temperature of water is observed to be as high as 30 degrees Celsius, and determine the minimum pressure allowed in the system to avoid cavitation. So in order to avoid the cavitation, the minimum pressure should be uh, greater than the vapor pressure. So that if we calculate the vapor pressure, or if you see the vapor pressure at saturation temperature 30 degrees Celsius, it comes around 4.25 kilopascal. So therefore, the pressure should be maintained above this particular case. So this is very low pressure. So generally, in the water distribution system, the pressure is well above this pressure everywhere. That's why this problem is not there in case of water. But the petrol vapor pressure at the same, suppose at 30 degrees Celsius, it is not 4.25, it is 52.5 kilopascal. And at 80 degrees Celsius, it is 227 kilopascal. So vapor pressure also increases with increasing temperature. Thus, there is a risk of cavitation at the higher fluid temperature, especially in case of petrol. In summer, temperature rises, and it is at 52.5 at 30 degrees Celsius, but it is close to atmosphere at 40 degrees Celsius. And I think the pump suction pressure is below atmospheric. So there is a possibility of cavitation during summer season in the petrol pump, like that, when the pump is used to pump the petrol from the down to the tank. So that's why the care is taken while designing the pump, especially for the petrol. So we have to ensure that the pressure there should not fall below atmospheric. Otherwise, the bubble will a bubble will form, and that bubble collapses at the high pressure side. So this is the importance of vapor pressure as far as the engineering perspective is concerned. It is definitely a property of fluid because it varies from property or property. Generally, this vapor pressure is compared at the atmospheric temperature. So that is 27 to 30 degrees Celsius. Water generally having a comparatively low vapor pressure as compared to other volatile fluids. So that's it. At the end of this particular lecture, you should be able to explain the concept of vapor pressure, what is the vapor pressure is all about. Then you should be able to differentiate the different characteristics of the features of the vapor pressure and illustrate the practical importance of vapor pressure, especially to how we can avoid cavitation. For cavitation, this particular property is very important. Thank you very much.